In this tutorial I am going to show you how you are going to estimate your mechanical properties, or you can say the rock strength within your TechLog. So basically you are going to estimate elastic properties and rock strength in TechLog in this tutorial. Before going into that, if you haven't subscribed to our channel yet, please subscribe and share it with your fellow geoscientists so they can also get some benefit from it. So let's start with it. If you are new to our channel, I have already made videos on data import, also on the pore pressure estimation and overburden stress estimation. So in this step I'm going to demonstrate that how you are going to estimate your elastic properties and the rock strength. In elastic properties I'm going to show you how you can estimate your isotropic properties, your elastic properties, your static bulk and shear modulus, Biot coefficient. In your rock strength you are going to estimate unconfined compressive strength, which is UCS, your tensile strength, friction angle and cohesion using UCS and friction angle. These are some of the prerequisites for the geomechanical modeling as well. So first of all, the logs you will be requiring for to do this task is basically you need compressional sonic, you need shear sonic, you need gamma ray, effective and total porosity, density and vertical stress, and apart from that you will also require volume of shale. So first of all I'm going to estimate my isotropic properties. So go to your this elastic properties tab and select the isotropic properties. It will ask you for data which is required, or the variables which are required for estimate these estimation. So I have opened this isotropic properties estimation tab. So from the project list select well T2, and from your data inventory select the libraries, and from there you select bulk density and drop it on the right. In the data type assignment select your compressional slowness and also drop it here, and the next is the shear slowness. From here you select shear slowness and drop it on the right, then hit create. Now all of my data set is under my dataset name logs. I'll drop logs dataset into this input or the workflow manager tab sorry. So here it has automatically selected those logs, row B, DTC or DTS. If I have two compressional slowness logs like DTCO1 or DTCO2, so it will give me those logs in my drop down menu. Right now I have only one, so I will select DTCO. If I have two, so I can choose among those from here. Now I'll just hit this computation button. So here you can see it has estimated my isotropic properties. What are my isotropic properties right now? I'll show you what it has estimated. So using these three logs, it has estimated or calculated Young modulus dynamic, bulk modulus dynamic, shear modulus dynamic, and Poisson's ratio dynamic. So there are dynamic elastic isotropic properties and there are static isotropic properties. The difference between dynamic and static is that static properties are estimated from the core data and dynamic properties are estimated from the log data. Sometimes you don't have log data, so you estimate your static properties from your log data. So basically they are sort of a virtual core readings. So basically now this is basically dynamic. So I'll save all these curves into my project tree. One by one select the curve and hit right mouse button and select save variable. Save variables. Save variable. Now we are done with the isotropic properties. Close this workflow layout. No, I don't want to save this one. Now the next thing we are going to calculate or estimate is the elastic properties, static elastic properties. We have few dynamic, now we are going to estimate the elastic static. Select elastic. Now it requires the Young modulus, Poisson's ratio, total porosity, UCS, compressional slowness, or the compressional velocity. So it requires UCS over here and the total porosity. So let's see, we don't have the UCS right now. If we can estimate UCS first, then we can come back here later. But first of all, let's see what sort of requirement is for estimating UCS. Go to the tab rock strength. Under rock strength, you have just UCS. Click UCS. So it will show you the sort of variable required to compute UCS. You need compressional velocity, you need Young modulus static, you need Young modulus dynamic, you need bulk modulus dynamic, you need shear modulus dynamic, you need compressional slowness, effective porosity, and shale volume fraction. We have all these parameters except Young modulus static. So for this one, you need a static Young modulus. One thing to note, all these tabs are grayed out. So if you remove one of these, it will still calculate your the required. At least you need to have one input, rest it will calculate by itself. So I'll just cancel out this one and go back to my elastic properties, and I'm going to estimate my elastic property static without UCS, and then see, I'll just delete UCS from here and import my total porosity log. And let's see how it will work. So here my total porosity. Now select hit create. So it's opening the workflow. So I have Young modulus dynamic, I have Poisson ratio dynamic, I have the total porosity, I have the compressional slowness. I don't have the compressional velocity. You can estimate your compressional velocity from your compressional slowness. They are the reciprocals of each other. The unit of sonic is microsecond per feet, but the velocity is meter per second. So they are reciprocals. You can just do the basic maths and convert dTCO to VP or compressional velocity. So right now I'm not using the compressional velocity as well. So I'm going to do the zonation tab. Then if you want to estimate it for different zones, you can go to your global zonation tab. Go to the global zonation. From here, select tops, or the top name with which you have imported your tops. I'll select tops. I'll select all. I'll hit this button, and my tops are in formation tops, or my zones are defined here, which I already defined during the data import in parameters tab. Now here it will be asking you about different parameters, different methods to calculate Young modulus static and other static properties. So here the method selected with the default value is the generic Fuller. So if you drop down this one, so there are a lot of different methods over here. Generic Fuller, for sandstone, the method is Plumb and Bradford. There's the Morales, then Morales excluding low porosity, modified Morales, Lacy, power law, linear law, exponential law, and constant. So these different methods are used to estimate your Young modulus static. So I'm going to go right now, just for an example, I'm going with Young modulus Lacy, limestone Lacy. What we can do, we just go to the Fuller, we use this one, and going to the static PR, Poisson ratio static, leave it as it is. For sensitivity analysis, do not change anything over here, and hit your computation button. So it has estimated your as we didn't provided it with the UCS value, so it didn't estimated your static PR or your Young modulus static, so it requires UCS as well. So first of all, we require to estimate UCS, then we'll come back to this one. I'm going to close this workflow manager. I'm going to rock strength in UCS. So here I don't have Young modulus static. I'm going to delete this one, and I am going to use the data from T2. All of them are selected over here. Effective porosity, I'm going to use effective porosity and shale volume fraction. There's one another way around for estimating UC and Young modulus using the Python in TechLog. I'll show you it later on. Shale volume fraction, I'm going to hit create. I'm going to drag and drop my logs dataset over here. So check your data, which curves are imported here. It's all okay. Going to the zonation tab, I'm not going to import the zonations here for now. I'm going to the parameters, and in parameters you have UCS method. You have to select the UCS method whichever you want to use based on your own regime where you're working, or the formations where you're working. These methods or the equations are like defined for specific regions or the specific formations, so you can use whichever is appropriate for you. So right now what I'm going to do, because different equations have different variables as input, so I am just going to go with this generic upper bound for sensitivity analysis. You don't need to do anything, just hit the computation button. Zoom in. So you see it has estimated your UCS over here. Just change its scale to view. I am going to hit F4 in the properties of UCS, and I am going to use the variable, or see the values are from 16,000 to 4,300,000. So I'm going to use the user from 0 till 200,000, and from kilopascal to MPa. Going to use megapascal. Or 2000 is, let's see, with the 20, no, 200, 2000, yeah, that will work. So that is your UCS. You can calibrate your UCS if you have the data from the course. You can calibrate it from there. I have used a generic method. You can use the method which is appropriate for your geological settings. I'm going to select UCS and save variable. Okay. I'm going to come back to estimate my static elastic properties. Now I have UCS. I'm going to use, now my UCS is selected here. I'm going to delete compressional velocity. I don't have the velocity function right now. I'm going to create. Now Young modulus, Poisson ratio, phi t, UCS and DTC are selected. Go to the parameters tab. I'm just right now using generic Fuller and hit play button. Let's see. Now you see it has estimated your Poisson ratio static and Young modulus static. You are going to save these variables. Save variable. Okay. So it has like estimated. Yes. I don't know where that come from. And Young modulus static. So static values are usually from your core data. So these are sort of pseudo core values which are generated from your logs. Close this one. Don't want to save it right now. Now we are going to estimate static bulk and shear modulus. You need Poisson's ratio static and Young modulus static. My Poisson's ratio static from here and a Young modulus static from here. Hit create. So it will not be asking you for any parameters. It will use these two variables to estimate your static and shear modulus. Hit computation button. So here are your shear modulus static and save these two variables as well. Okay. Bulk modulus static, save variable. Okay. close this layout. Now we are done with our almost all the elastic properties. Now we are going to estimate Biot coefficient. It requires effective porosity, bulk modulus, static, and permeability. I don't have permeability right now. I'll delete this one. If you have the permeability curve, you will use that one. So I'm going to go with these two. So I have the effective porosity and the bulk modulus static. In the zonation tab, you go and select your zonation and parameters. You have to like give the method you are going to use. So I'm going to use generic macro alpha. There are different other methods as well: keep porosity, macro alpha, constant, and compute all methods. So right now I am going to use the method from the bulk modulus, or you can use this custom the constant. In the constant, if I select this constant method, you have to use this constant value for different formations. So I'm not going to use this one. I'm just going with this macro alpha bulk modulus static, and or maybe you can go with the porosity one. Let's go with the porosity one and hit computation button. Or if you know your Biot constant value for every formation, so no need to compute that one. If you don't know your Biot constant value, so you have to estimate this Biot. It's very important when I'll come to the part where I'll show you the wellbore stability analysis. So it plays a very important part during your wellbore stability analysis. So you need to have certain values for your Biot constant. So I'll just compress this scale, and I'm going to save this variable alpha. Save variable. Okay. So its values, usually Biot constant values, varies from 0 to 1. It depends upon the porosity, depends upon the strength of the rock, depends upon the pore throat structure, what sort of fluid is inside, what sort of pore pressure is inside. So I'll close this workflow layout. So almost all of the elastic properties are done. Now I'm going to my rock strength again. I have already estimated rock UCS, which was required to estimate the static properties. Now I'm going to estimate my tensile strength. You need UCS for TSTR or tensile strength. Select this one. Go to the parameters. If you want to define different parameters for different zones, you just define import your parameters from your zone or your zones from your zonation, global zonation window over here. I'm not going to do that right now. I'll just hit the computation button. So here is my tensile strength. It's in PSI. I'll save this variable. Alright. Save a flow layout, no. Now next thing I'm going to estimate is the friction angle. You need gamma ray, shale volume, fraction, compressional slowness, and porosity. If you want to give the porosity, you can give it. If you don't want to give the porosity, it's up to you. I'm just not going to give porosity, or let's give total porosity here, or I'm going to find out where your T2. selected one T2, and in T2 my total porosity is here. Create. So all my values are here. In zonation tab, select the zones. If you want to import your zones, in parameters tab you have to select the method. So whatever the method you want to use, you will select from here depending upon your local geology or your understanding of the local geology. I'm just going with the friction angle method, which is LAL. This is usually used most of the time, so I'm just going with this LAL method. And in sensitivity analysis you don't need to do anything. One thing later on, I'll explain that later on. Just hit the computation button. So here is your friction angle. The important thing which I wanted to tell you earlier, that you have to see QC this your friction angle. Wherever you have a shale, you have to check the friction angle over there. If it is more than 40, you have to apply a limit that it should not go beyond 40, because you cannot have a friction angle. It's not possible to have a friction angle more than 40 degrees in shale. So be aware of this thing. Right now if I see here, I have more than 40 degrees angle in shale, so I have to apply some cutoffs, that if my friction angle is more than this degrees in this formation, restrict or limit it to 40 degree. So that you can do in the Python script, but right now I'm going to go with simple this variable which is estimated. I'm going to save this one, because right now I'm just showing you the whole workflow, not the theoretical part. I'm just going through the practical part. How do you compute these variables? I'm going to close this workflow layout. The last thing from this today's tutorial is the cohesion from UC and friction angle. You already have computed your friction angle and UCS. Hit create. In zonation tab, to want to import your zones, you can import it. Your friction angle is selected because you have already saved in your project tree. Going to the parameters tab, there is no parameter required. Just hit computation button. So here is your cohesion. Just select the cohesion button and save variable. Okay, so your cohesion is saved over here. So all of your elastic properties and rock strength properties are saved in your project tree. You can group them in your project tree as elastic and rock strength properties. I am going to group them as elastic properties right now. You select all your computed parameters which you just computed under elastic and rock strength, elastic properties and rock strength. I'm going to select all these. When you select all these, press right mouse button and from here select group and give the group name. Suggest a name. I'm just going to use elastic properties. This is how you can give order to your input data set. Now all of your things has been arranged in your project tree under your dataset logs. Sometimes you have to find certain curve, so you can just go to your group and find it from there. If you haven't group these parameters or the variables, you can go to the search and write the name of the parameter or the variable. So that is sort of hectic job. So grouping and cleaning your project helps you during the long projects when you are working, so it saves you time. So folks, that's it for now. I hope you understood all the method. Do comment in the comment section with your feedback. If you liked our video, share it with your fellow geoscientists. If you have any query, any sort of confusion, you can just comment there, or you can just shoot us an email. I'll provide my email address in the description box. So I'll be more than happy to help you guys. So see you in the next tutorial, where I am going to show you how to estimate the horizontal stresses, and then at the end we'll be going to do the wellbore stability analysis. So okay, for now, bye. See you in the next video. Bye bye.